Hey guys, let's record some solutions to some homework problems. We want to approximate this integral using a Riemann sum. It's going to be a right-hand Riemann sum with n equals 8. The interval from 1 to 3 is what we want to do this over. N equals 8 is telling me to cut that into 8 pieces. The starting interval has length 2. Dividing that into 8 pieces will be 1/4 is the length of each piece. We call that the delta x. So cutting the interval from 1 to 3 into pieces of length 1/4, I get 1 to 1.25, I get 1.25 to 1.5, then to 1.75, then to 2, then to 2 1/4, then to 2 1/2, then to 2 3/4, and then to 3. For each of these intervals, I need to pick a representative point that's going to be the point that I plug into the function. They told me to make a right-hand Riemann sum, so I'm going to pick the right-hand endpoint and plug all of those points into the function. I need to take the points 1.25, 1.5, 1.75. What am I doing with these points? I'm plugging them into the integrand, so I need that squared minus 15. Plus I need that squared minus 15. Plus I need that squared minus 15. I need 2 squared minus 15. 2.25 squared minus 15. 2.5 squared minus 15. 2.75 squared minus 15. 3 squared minus 15. I need to add all those up and multiply them by the length of their representative intervals. That was the delta x, that was the 1/4 we used. So this number is our answer. I want to type it in. I guess it's easier if I group the 15s together. Like it'll be less typing. It's 1.25 squared plus, so the last one is 3 squared. Minus 15, minus 15, minus 15, minus 15. This is 8 15s. 8 times 15 is 120. So that saved me a little typing, but I still got to add up all those squares. Let's do that. So adding up the squares part, this thing gave us this number 38 3/4. Now I need to do the negative 120 and multiply by 0.25. And we get the integral of about negative 20.3125. That's our estimate for the integral. What's up next? Problem 3 is actually evaluate that integral. What was our function? We want the integral from 1 to 3 of x squared minus 15. That starts by graphing the function. X squared minus 15. Make sure you have a window that includes the region from 1 to 3. Negative 10 to 10 includes that. Show me that graph. Hey, there's that graph. It goes below the window, that's fine. Second trace is calculate. 7 is calculate the integral. What are the lower and upper limits? The lower limit is 1, the upper limit is 3. So I want to go from 1 to 3. I get negative 21 1/3. What is that, negative 64 thirds? Hey, that was pretty close. Cool. I want to sketch this graph on the interval from 0 to 3. It's a line. Plug in 0, you get negative 4. This is the y-intercept. Plug in 3, and you get 2 times 3 is 6 minus 4 is 2. So I got this point. I got something like that. Looks like it has when I drew it had an x-intercept at 2. Is that right? If I plug in 2, 2 times 2 minus 4, yeah, that is 0. So this does cross the x-axis at 2. I'm probably going to care about that. I want to compute the integral from 0 to 3 of this function. The integral is the area under the curve, so I want this area and I want this area, but with the special weird rule that area below the curve counts as negative for an integral. So these are triangles. What's the area of a triangle? The area of a triangle is 1/2 base times height. The little triangles got a base of 1 and a height of 2. It's half of a 1 by 2 rectangle, so its area is 1/2. 1 times 2 is 1 for the little triangle. For the bigger triangle, the base is 2 and the height is 4. So his area is 1/2 of 2 times 4 is 4. But this one counts positive and this one counts negative. So the integral is 1 minus 4 is -3. I can get my calculator to compute the integral and verify that. I want to approximate this integral from 0 to 15. So again, above the x-axis counts positive, below the x-axis counts negative. The point of this was the box counting thing. I want to estimate the area by counting boxes. I do the thing where a whole box counts as 1. So I have 4 whole boxes. And then I have some partial boxes. I have 1, 2, I have a tiny bit of that, I have most of that, some of that, some of that, some of that. So I have 1, 2, 3, 4, 5, 6, 7 partial. These are my positive boxes. The part below the x-axis is going to count negative, but I do the same box counting thing. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 whole boxes. How many partials do I have? I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 partial. Some of these partial boxes are more than half a box, some are less than half a box. People get mixed up about what I'm counting. The thing I'm counting is, I want to understand this region, right? I am counting how many boxes are in that region, and how many boxes are part of that region. So this box counts because part of the box is in that region. Sometimes it's more than half, sometimes it's less than half. You kind of just trust that it'll average out to be about half, and you count these as half a box. Our positive part is 4 plus half of 7 is 7.5 boxes. Positive area. I have 11 plus half of 10 that's 5, so 16 boxes of negative area. 7.5 minus 16 is -8.5 boxes. So we've estimated that the integral is about -8.5 boxes. The thing we haven't done yet is how big is a box? I count these tally marks. This went by 5, so a box has a width of 1. How tall are these boxes? 20, counting by 4s, so 5. Each box is a 1 by 5 box, has an area of 5. So the thing we want is the area, not the number of boxes. And the box has a representative area of 5. 8.5 times 5 is -4250. We estimate that the integral of the function from 0 to 15 is about -42.5. Cool. Here's a function that's the value of my house. T has been measured in years since 1990. Find the average value of my house over the last 5 years. Okay, right now that's going to be from 2015 to 2020. I'm not going to try and figure out what part of a year we're in. If you did that, that's fine, I guess. So that's T equals 2015 is how many years since 1990? 25 years since 1990 to T equals 30. We want to know what's happening from T equals 25 to 30. We want the average over the interval from 25 to 30. The average value of a function is 1 over the length of the interval times the integral over that interval. Next video.